Thanks for tuning in at Brackies.
Hello everyone and welcome to video number 7 on making a multiplayer FPS in Unity. In today's video we're going to take a look at damaging our player. So we'll be introducing a health variable and a cool system for kind of keeping track of players in our game. We'll have this dictionary that associates a player ID with an actual player component. But before we get started, I quickly want to apologize for not making a video last week, but I got sick. But I'm fairly healthy now, so that's good. And also next week you might not see a video either because I'm attending DreamHack in Sweden. If you don't know it, it's this huge LAN event. It's really awesome, and I'll probably tweet a bit about it while I'm down there, so stay tuned for that. And also, as always, if you have any questions, go to forum.brackies.com. So you can basically go ahead and skip right here, use the annotation on the screen to the actual video, but I quickly want to answer some questions that you guys have left in the comments about preventing cheaters in the game. So in on the last video, you guys wrote that it would be a good idea to kind of shift the raycasting, the shooting mechanic, from the client side to the server, because clients, well, they can't be trusted. And you're actually very right about that. And I did write to you that I wanted to just change it in this video. However, I thought about it some more, and a lot of problems kind of arise because we can't just change the raycast over, and that would be a fairly easy process. We would have to do some layer management and that, but we could do that. But there would still be a lot of issues because some important variables like our damage variable, and in the future we're going to have a rate of fire and stuff like the range and all that would still be very exposed to cheaters, so it wouldn't really prevent anything. And we would have to move all of that logic over to the server, and things start getting really comprehensive and difficult. So, and kind of without the scope of this tutorial. So what I suggest we do instead is we continue making the game with a minimal amount of security. And what I would really recommend you do is if you find your game to be fun and you want to publish it and expect to get some users and maybe some that want to cheat, well then I suggest you check out find some kind of asset that will prevent cheating. And there are a bunch of solutions for this out there. I mean, these guys have put their lives work into preventing cheaters. And the one that I would recommend is what is called Anti-Cheat Toolkit, and it's on the asset store. It costs $30, but it's very easy to implement, so it's not something that you need to buy right now, but it's something that you can think of buying once you feel that your game is ready to be launched. The most important functionality I believe in here is the ability to kind of protect your types, protect your variables so that it's not easily to insert a new value into them. So you can protect the damage variable so players can't do insane amounts of damage. And they also have stuff preventing wall hack and speed hack and stuff like that. So this is a really good toolkit. It's very easy to use, and I suggest you check that out if you worry about cheaters or another solution. It's completely up to you. So that's just my reasoning behind this, and now I think we should move on to today's video. So we're here in Unity, and the first thing that I want to do here is just take a look at the player. And if we just double click on the player shoot script and open it up in Visual Studio, we can kind of see where we left off in the last video here. So move this over here and scroll down, and we can see that we have this command, which is of course called on the server, that takes in an ID and then says that that ID has been shot. Well, now we need some kind of way for us to easily find the player with this ID and then call a method on that player. We could create a player script or a health script that will subtract a certain amount of health. And I think a good way to do this would be to introduce a kind of central game manager component that has a dictionary of players in it. So what we're going to do is we are going to rename this from ID to player ID. and do the same down here. And we can just leave the debug.log statement here, and this will only be called on the server. And what we can then do is we can go ahead and create a new component. So let's go under create and then C# script. And let's name this the game manager. And while we're in here, let's also create another C# script. And let's name this the player. So this is our central player component. You can also call it the player manager if you want. And let's just go ahead and open up the game manager here. And the game manager is of course going to be of type network behavior. But actually, as I'm thinking about it, I think we can go ahead and keep this as a mono behavior for now. And then we'll add onto it later if needed. So basically, I want to create a static dictionary in here. So we are going to be using system.collections.generic. So that's something you want to type up here. And then we are going to create a public. Actually, I'll make the list itself private, and then we'll access it through public methods. So a private static dictionary. And it's going to take in as the key a type string, that's going to be ID, and it's going to give us the value, which is going to be of type player. Remember the component that we just created? Well, that's a component that we want all of our players to have, and therefore, well, it makes sense to use that component and not a game object or anything else, because this then that way we restrict ourselves to only having players in our dictionary and not other game objects. And then we call this players, and we set it equal to a new dictionary of type string player, and then open close parentheses and a semicolon. So that's kind of the syntax for creating a dictionary here. I believe it's the first time we do this on this series. So then we need some methods that will actually interact with this dictionary. And the first one is going to be a public void, and it's simply going to register a player. And of course we want some arguments here, and the first one is going to be a string, and we are going to call this the net ID. We are simply going to be taking in the network ID from the player's network identity component, and then we're going to be kind of transforming that into a player ID, so we can give it any kind of format that we want. And then we're going to also be taking in a player, of course, so a player underscore player. There we go. And we could just say that, well, the player ID and net ID should be the same. If you don't know, when a player joins, he gets assigned a number. That's his net ID. And by default, that's just going to be 1, 2, 3. So the first player is 1, the second player is 2, and you get the idea. But instead of kind of just renaming all of our players to 1, 2, and 3, we should maybe call them player 1, player 2, or player ID 1, or whatever format you want to kind of do for this. So I want to just prefix this net ID with another string. And instead of hard coding it down here, we could just say that the string player ID should be equal to player plus net ID. Well, then I just want to kind of create a variable up here that's easy to spot and change. And we're simply going to call this, we're going to make it a private constant string because it's not going to be changed. And with constants, the naming convention is all capital letters. So we're going to call this the player prefix, ID prefix, like this. And we'll simply do player like that. And then we can simply take this down here instead. So we can change it up here and it's easily visible. Cool. So we get the player ID here, and now we can simply go in and add this to the dictionary. So we can say players.add, and you can see it takes in first a key and then a value. And the play is going to the key is going to be player ID, and the value is going to be player. There we go. And I also quickly want to rename the player transform to the player ID so that we can quickly see what players are what in the hierarchy. And in order to do this, we're simply going to say player.transform.name equals player ID. There we go. And I believe that's all we need to do inside of this method. So now in the player setup, you can see that we have this start method that disables the components, enables the camera, or disables the scene camera, and then it registers the player locally, and all it does is it says sets our transform.name equal to player plus the net ID. So that's kind of the same that we've done here, but now we can remove it here and know that the game manager takes care of this for us. So I'm actually going to move this completely out of the start method and then instead create another method, a new method. We're going to say public override void, and it's going to be on start client. And on start client is a method already in the network behavior class. And it's basically called every time a client is set up locally. So what this will allow us to do, you can see it calls its own base here, is we can simply add the register player onto this. So we can now say game manager dot register. Oops, did we not do this correctly? Game manager. This of course needs to be static too. Game manager dot register player. There we go. And then we give it first off the net ID and then the player itself. So we need to get some components here. The first one is going to be the net ID, and that's going to be equal to get component network identity dot net ID. And the second one is going to be the player itself. So that's going to be underscore player equals get component player. There we go. And we can simply put these in here. So we give it the net ID and the player reference. Whoops. Cool. And we know that of course we need to convert this to a string. So we call the toString method. We know that the network ID is always going to sit on this because it's of type, it derives from network behavior and therefore it requires a net ID. But we want to make sure that it always has the player component, and therefore we should require it up here. So we'll call require component type of and then player. There we go. So now we'll always get a valid component here and not a null type. So this will just work and we don't need to do any error checking. Now down here in the onDisable method, well, we want to of course also deregister players once they are killed. So under the game manager, we can now say dot unregister, and we'll create this in a second. Unregister player, and we'll give it the ID of the player with this, which is equal to transform.name. We could also pass over the player component and search for that, but we'll just give it the ID. It's the ID because that would be easiest. So of course, registering and deregistering players is something that we will do once a player joins and disconnects, and this will do that every time a player joins and then when he is destroyed. And that's not the same as him disconnecting. Right now it is, because we don't have any way to destroy our player other than if we disconnect. But at some point we're going to have to make a distinction there. But for now we'll write it in like this and we'll handle things as they come. So now we can make a public static void called unregister player. Actually, this should probably deregister. You English talkers are going to probably correct me on that, but I'm going to write unregister and face the facts it doesn't matter. Okay, so we'll take in a net ID, a player ID of course, and we'll basically say that players dot remove and then give it the key, which is player ID, and it will be removed from the dictionary. And it's that easy. So when it comes to dictionaries, they can be kind of hard to work with in Unity because Unity doesn't have a way to actually visualize these in the inspector. So you have to kind of create your own UI if you want to do that. We could go down here and create a onGui method that lists all of the registered players, but I don't really think it's something that we should be spending time on right now. I'm thinking about it. Okay, you know what? Let's do this. So we'll create a void onGui, and in here we're simply going to be using Gui Layout. So we'll say Gui Layout dot begin area, and we're going to give it a new rectangle. This is by no means something that you need to do. This is just something I'm doing to visualize what is going on. And you can just copy off me here. I'm not going to be explaining too much. So we are creating an area for GUI to reside in, and that's going to be at 200, 200, and with the width of 200 and a height of 500. And of course, when we begin something, we have to end it. So end area. And GUI layout dot begin vertical, GUI layout dot end vertical, and so now we will list things like like this, and then we can loop through our dictionary here. So for each, what are we going to do? Player in, and we'll just call this player in players. Is this gonna work? I don't remember how the proper way to loop through a dictionary is. Give me just a moment and I'll check what we are going to do here. So of course I was being a bit stupid here. Well, we want to loop through the keys, so we are going to create a string here for each player ID in players dot keys. That's going to be the array storing all of our keys. But then we want to create a GUI layout dot label, and this is going to store our ID first. So we're going to say player ID plus, and then we'll just create some space here. And then the players, and then we're going to input the key in order to get the value. So we're going to say player ID here, and then dot transform dot name. So we'll give it the name there, and that should be fine, I believe. Cool. So we'll just create a bunch of labels here and lay them out. I think that should work, and we'll test this in a second. But also I want to create one last method, which is kind of just a utility method for getting a certain player with an ID. So we'll create a public static void get player, and it's going to take in a string player ID. And of course its return type is going to be player and not void. And it's simply going to return players and then input the player ID, and we'll get the value. There we go. And that's basically all for our game manager. So now under our player setup, we can see that we are setting up the player, we're registering him, and we are deregistering him down there. And then in our player shoot script, we can use the get player, but we're going to do that in a second. For now, let's just check that these players are appropriately added to a list. So you can see here that something is going wrong. And what is going wrong here? So reference not set to instance of an object. Well, first off, we need to make sure that our player here actually has the player script attached. And he might not, because, well, remember, we added the require component after actually having added the script, and therefore that sometimes won't work. So yeah, we'll simply drag that in. So all we need to do is find our player, log that on there, take our player script here and add it onto there. And now that that is added, we also need to create. Actually, right now everything is static with this game manager, so we don't need to add it, but I don't think everything is going to be static. So therefore I'll create an empty game manager component up here, and we don't need that locked anymore, and we'll reset that and add the game manager onto there. For now it's just gonna sit there and do nothing because we don't instance this in any way, but at some point we probably will. So now let's clear this out and hopefully we will get no errors. LAN host, and you can see here that it says player 1, that's the ID, and it's associated here the player 1 up here. And I know it looks stupid that it just says player 1 and player 1, but it means that it's actually working. And of course we had to add this here because we've done the GUI stuff. So it's a great thing that we remember to do that. So now if we just go ahead and build this, it's not going to be kind of especially impressive in any way, but we are going to see the fact that we have this central manager component that keeps track of our players. So let's hit play there, go under host here, select client over here, and you can see that we have the 2 players in here in the dictionary. So that's just a way for us to visualize what is going on. Cool. So that was all we needed to do. Now we can actually go ahead and use this. So I'll just go under the game manager here and comment out this on GUI method. We might be needing it at some point, but not for now. So under our player shoot script, you can see that we are currently just writing out what player has been shot. Well, we can use this information to do much more. So we are going to call GameManager.getPlayer, and this will of course return a player object, and we're going to input the player ID. And therefore down here let's create a player object, and let's just call this player and set it equal to that. Now we can call methods on that player component. So let's go ahead and make a method for this. We can say player.takeDamage, and we can give it the damage amount. But in order to give it the, and this is a method we're going to be creating in a second, in order to give it the damage amount, we of course need to pass this on. So down here, when we call the command, we give it the ID, which is the collider's name, and we also want to give it the player or the weapon.damage variable. And I've changed my mind. I don't want this to be a float. I want it to be an integer. So up here, we're just going to say int damage, and we're going to pass it on down here because we want to pass it into the take damage method. And now we need to go under the player weapon script and change this from a float to an integer and just remove the F here. There we go. So now all damage is calculated with integers, and so will our health. So now we can go into our player script and actually configure that. So let's open that up. And in here, this is of course going to be of type network behavior, and we need to be using Unity engine.networking as always. And we are going to need to create a couple of variables here. So the first one is a public. Actually, I don't want it to be public, I just want it to show up in the inspector, so we're going to make it a serialized field, and we'll mark it as private, and that's going to be an integer storing our max health. And let's just default that to 100. Then we're going to have another variable, and this one is definitely going to be private, and this is going to be our current health. And we don't want to set that equal to anything yet. However, our current health needs to be synced across all the different clients. So it would be really stupid if we damaged the player and the only one who knew we damaged the player was the server. The clients were never notified of this. And if we just go in and change this by using this command and calling a take damage function on the player, well then it's only going to be changed on the server. So in order to sync this information about the value being changed out to the all of the different clients, so that they can update their GUI or kill off the player if he died and all of that, Well, then we need to create a sync variable. And all we have to do in order to mark this as a sync variable is simply use an attribute. So we just type in sync var. And now every time the value changes, it will be pushed out to all of the clients. It's that easy, and this is an amazing feature in uNet. So that's all we needed to do there. And then we can maybe say in the start function here, or we could do this in awake even. We can simply call some kind of method that will set our current health equals max health and all of the other stuff that we might want to reset in the future. So let's create a set defaults method. It's not going to take in any arguments at all here. And we're just going to create that down here, and we're going to make it public because I imagine that we're going to be calling this from outside the script. And it's going to be called set defaults. And it's simply going to say that current health equals max health. And it's that easy. Cool. And next up, a public void take damage that takes in a amount and simply says, well, we want to subtract our current health with the amount. And again, we don't need to do anything here. It's going to be synced out because we marked this as a synced variable. And then we can just debug.log, and this is only going to be done on the server, of course. So you're going to send out a debug.log statement saying that transform.name plus now has plus current health plus health. There we go, so we can see the health updating in the inspector. And of course, this is again only called on the server, so only the host will be able to see this in their console log. But that's okay for us. So now we actually have this structure in place where our player checks, all of the different players check locally if they hit something. If they do, they send over information or an ID of what we've hit and some damage. This is called on the server. So the server now takes the information about this ID and finds the player component by using a utility method on our game manager that tracks all of our different players. It then takes our damage variable and puts it into a take damage method that we call on that player. We jump over here. The player locally on the server applies this damage to the current health variable, and Unity recognizes that this variable has changed and then syncs it over out to all of the clients. So that's kind of the route that that's kind of how the networking is working in this case. And I hope you can follow along here. If not, don't worry, you'll get a hang of this in no time by just playing around with it. And if this is working, well, I hope it is. Let's test it out. So let's build this. Actually, I'll just build it locally here so we can see if there's any errors. There aren't. So let's build this to a standalone and see if it's actually working for us. We'll also build it here. I'm going to select host here and client here. We'll move up here and shoot the guy. You can see here that it says player has been shot. Player 1 now has 90 health. Remember, we start at 100 and we subtract 10. And we can actually view this if we select our player 1, and you can see that this is indeed the first player to join. This is the host. We can then actually inspect the private variable here. And this is a fairly handy feature. If we go up here in the inspector, we can change to debug mode, and a bunch of information is going to be appearing, but this will allow us to view private variables. And you can see down here now that current health is indeed 90. On player 2, it's still 100 because we haven't hit that player yet. Let's try and actually do that. So let's try and shoot that player. So I'm going to shoot him here. Click. You can see player 2 has been shot, Player 2 now has 90 health. I'm going to do this a few more times, bring him down to 60. And you can see here that current health on player 2 is indeed 60. And this is going to work regardless of who is hosting. So you can see here that we got a timeout error. That's because the host disconnected there. We can simply close the developer console. Let's now host on this system. Let's host on and join as a client on this system. And you can see we don't get any errors because we are properly registering and deregistering players into the dictionary. Well, you can see that I can shoot this player 2 times and I can shoot this player 3 times. Nothing is appearing in the console because this is the one, this client is, this game instance is the host, and therefore all console logs are being sent over here on the server. But we can see that it's still updated. So down here, this guy now has 70 health and this guy has 80. So that was basically it for damaging players, syncing damage over the network, kind of keeping track of players in a intuitive way using IDs. And yeah, I don't have any more to show you today. I hope you were able to follow along, and maybe I'll see you at DreamHack. Until then, enjoy.